A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. So when you look at its graph, when you look at a uniform distribution graph, it's going to have a rectangular shape, similar to what we have here. Now our values are typically between A and B, so when we're looking at the area here, the shape, it's going to be this square-like shape. So what we're looking at is going to be between A and B, that is along the horizontal axis, and this is the values that you are looking at, like time or distance or something like that. That's the horizontal. Whereas the vertical axis here, 1 over B minus A, that's the probability of it happening. So this is the shape that we typically deal with. So some facts about uniform distribution that you should know. First, the area under the graph has a probability distribution to 1. That just means that if you add up all the probabilities from A to B, you will get 1. So the area here is 1. And this is very important, there is a correspondence between area and probability. So some probabilities can be found by identifying the corresponding areas. So when we say areas, we mean probabilities. When we say probabilities, we mean areas. They are interconnected. They are essentially one and the same. So it happens with uniform distribution and a lot more useful when you come up to normal distribution. They will say area or probability interchangeably. So be very mindful of that. But don't get confused. They mean the same thing. So let's look at an example. The Florida Power and Light Company provides electricity with voltage levels that are uniformly distributed between 123 volts and 125 volts. This means that any voltage amount between 123 and 125 is possible, and all possible values are likely. So let's use our table, or our chart here. So A will be our 123, and B will be our 125. So everything has to be between 123 and 125. So this square rectangle shape here. And we want to know what is the probability that the voltage is greater than 124.5 volts. So 124.5 we'll say is somewhere right here. Not 100% accurate, but we're going to say it's here. So that's 124.5, and we want the probability of getting something in this little sliver. So what we're going to do is we know that our universe is between 123 and 125, and what we want is between 124.5 and 125. So what we're going to do is the probability of our x value being greater than 124.5. So the way to do this is to find the sliver area. So between 124.5 and 125 is actually just going to be 0.5. And then the distance between 123 and 125 is just 2. And then you just do the arithmetic here. 0.5 divided by 2 is going to give you 0.25. So the probability of voltage being greater than 124.5 is 0.25. That's all there is to uniform distribution. What you're looking for divided by the total essential universe that is possible. Now, what is the probability that the voltage is between 123.7 and 124.9 volts? So, probability being between 123.7 and 124.9. So again, 123.7 to 124.9. So in our chart here, it would look like 123.7, we'll say is like right here. And 124.9 is going to be pretty close to 125, so we'll say right there. And we want the area between these two. So again, we're just going to subtract these two values here and divide it by the difference between these two values here. So again, we're going to get 124.9 minus 123.7, and that's going to give us 1.2 divided by 2 again. And when we do that, we're going to get 0.6. So the probability that is between 123.7 and 124.9 is 0.6. Now, what is the probability that the voltage is less than 123.7? So probability X is less than 123.7. Now, go back up here, just look at what our chart would look like. And we already have the 123.7 already set up for us. Just need to change where the area is being shaded. It's going to be this little sliver over here. So again, we're going to do 123 minus the lowest part, which is 123, and then divide that by the difference between A and B. So we're going to end up getting the difference between 123.7 and 123 is going to be 0.7 divided by 2. And when we do that, we're going to end up getting 0.35. So the probability that the voltage is less than 123.7 is 0.35. Just remember, for uniform distribution, you need to find the difference between the two values that you're looking at, whether it's two values like here in part B, or if it's part A or C, where you take the value and go up to the maximum amount that you can go, which is your B value that we did here with 125, or in part C where it was less than 123.7, we subtracted that from our A value. And then we just divide the two, and we have our answer for uniform distribution.